Hi there, it's Mrs. Tremblay. It is time for a new form of linear equations, our third and final form. We're on lesson 2.6, writing equations in point-slope form. A linear equation written in the form of y minus y1 equals m times the quantity of x minus x1 is in point-slope form. The line passes through the point x1, y1, and the slope of the line is m. So this form is used when you are given the slope and you're given 1 point from the line. So the x1, y1 in this is at 1 point from the line, and the m is m. The y and x are going to stay letters just like they did in all the other equations. Alright, so you don't need to have a y-intercept in this form. This form can be used with lines that have this form cannot be used with lines that have undefined slope. So just to kind of show you why it works, because hopefully I'm not the only one that thinks that this is super cool. Hopefully you'll enjoy it. So who came up with this crazy formula? How did they come up with it? Well, you know that slope is equal to, and yes, write this, y2 minus y1 over x2 minus x1, right? Alright, so you've solved proportions before, right? So if I'm saying m equals this, then I could say m over 1 equals that, right? And you've learned that when you're solving proportions, don't you cross multiply. Alright, so here's so exciting. If you take 1 and you multiply it by that, whenever we multiply 1 by anything, we get that same amount, right? So y2 minus y1 equals, and then I need to take m times that entire amount, right? So it would be m, and then I'd have x2 minus x1. Right? That's crisscross applesauce. That's how you would solve the proportion. Does this look at all familiar? Does it kind of look like that right there? Yes. So it wasn't just made up magically. It just, somebody came up with this, they figured it out, and were so kind enough to share it with the rest of the world. So the only thing that's different is we don't have these ones in this other equation here, and we just plug in values with the 1 point that's given. So I want us to be able to, first off, write equations using slope and a point in this form. So all you need to do is substitute x and y from the given point for x1 and y1 and plug in the slope for the m, and then you're done. It's really that easy. So let's try a few. Try it, you might like it. It says, try it, write a linear equation in point slope form for the line with the given slope and the solution point. So we're supposed to take our x and y and plug those in for x1 and y1. So I'm supposed to take y minus y1, which is 1, equals the slope times x minus x1. That's it. That's all I need you to do so far. Yes, it'll get a little more complicated later, but I like to start off nice and slow. Alright, let's try another one here. So this is my x, this is my y. I am supposed to take y minus y1, be careful there, equals the slope times x minus x1. Alright, now for this one, I probably wouldn't leave this as minus negative 4. I would change this to y plus 4. You usually don't see things written as minus negative like that. But for now, either or would be fine. Alright, let's try another one. Alright, y minus, and this is my x, this is my y minus y1 equals the slope times x minus x1. Crazy, I know. You could fix this one up a little bit too, and it would just end up being y equals x minus 7, but for now we're supposed to leave this in point slope form, so we'll leave it. Alright, last but not least, y minus y1 equals the slope times x minus x1. And I want to clean up subtracting that negative there, so I'm going to change this to y plus 5, and I'd have negative 3/4 times the quantity of x plus 8. Lovely. Hopefully so far so good. Alright, let's move on to the next page. Let me find my next page. Got all kinds of notes down here. I'm in my basement. Alright, if you hear screaming and yelling, it's probably my children upstairs. They're being pretty quiet right now, though. So writing equations in slope-intercept form, if you're given 2 points. So this time, instead of giving you the slope, I'm going to give you 2 points. But the good news is, you know how to find slope from 2 points, right? You use y2 minus y1 to find the m, and you can choose either one of the points, x1 or y1, or x2, y2. It doesn't matter. They're both solution points. And you'll solve the equation for y, and that will give you your slope-intercept form. So our goal is to write equations in slope-intercept form, given 2 points. Now, if I gave you, in a previous lesson in 2.3b, I had you write an equation from 2 points, but one of the points given was a y-intercept, right? And I said later on you're going to learn how to write this equation after we have a little bit more background knowledge. Well, now's the time. You can't just write an equation in y equals mx plus b form for this, because all you can find is the m. You don't know the b. So using your point slope form allows you to rearrange it and figure it all out. So, following the steps, number 1 says, start by using y2 minus y1 over x2 minus x1 to find your slope. So to find your slope, we're going to take y2 minus y1 over x2 minus x1. So we would have negative 6 over 3, which would equal negative 2. So I know my slope is negative 2. And I told you you could use either one of the points, right? It doesn't matter which point you pick. We're going to choose, and I usually just go with the first one as habit, but I'm going to make these my x1 and y1 in that point slope formula right here. Alright, so point slope says, I'm supposed to take y minus y1, which is 4, equals the slope that we just found, times x minus x1. Now we're not done because I wanted the equation in slope-intercept form, so we just have some rearranging, some simplifying to do. We know that we get rid of parentheses first whenever we see them, and I'll keep change. So negative 2 times x is negative 2x, negative 2 times negative 2 is 4. Now to get the y by itself, I would add 4 to each side, and I end up with y equals negative 2x plus 8. Voila! So that means that these 2 points are solution points on this line. Those 2 points would fall on that line. And I'm not going to do this for every single one, but I do want to show you that you can actually, you could use the other point and it doesn't make a difference. So if I plugged in and said y minus negative 2, so y minus y1, or y2 I'm using this time, equals my slope times x minus 5. So I use this ordered pair instead. You can't use like a 2 and a negative 2, like you can't take one from each. You have to either take this point or this point. So this really means y plus 2, right? So y plus 2 would equal negative 2x plus 10, and then we would get rid of that 2, and I'd end up with y equals negative 2x plus 8. Oh my goodness, it's exactly the same. So I wasn't lying to you. I try not to lie to my students, you know, it's just not good. So I'm being truthful when I say, pick the first one, pick the second one. It doesn't matter which one. You're going to get the exact same answer. If I see 2 positive numbers, I usually go with that one because then I'm less likely to make silly errors later on with the negative signs. Alright, let's try it. We're going to work through these steps and write an equation of the line that passes through those 2 points. Your step 1, I need to know the slope. So the slope is equal to y2 minus y1 over x2 minus x1. Oh, I didn't really need to do that. Keep change. I just get so in the habit. 9 minus 6 is 3, yes. And negative 2 plus 8 is 6, and our slope is 1/2. Now I'm going to choose one of those points, and I just always choose the first one. I don't know. You could choose a second one and then work through the problem. You'll see that you get the same thing. I'd be okay with that. Alright, so the formula says y minus y1 equals the slope times x minus x1. And from here, we just need to solve for y. So I would have y plus negative 6 equals 1/2 x plus 1/2 times 8 is 4. To get y by itself, we would add 6. And y is equal to 1/2 x plus 10. Voila! You're done with that one. All right, last one like this, then we'll move on to some math stories. I know, what would a lesson be without story time? Alrighty, so here's our points. Find your slope first. y2 minus y1 over x2 minus x1. -4 plus -1 is -5. 3 plus 2 is +5, and -5 divided by 5, yes. It is -1, so your slope's a -1. Now, choose an ordered pair and plug it into y minus y1 equals a slope times x minus x1. And we'll solve it for y. I'm going to keep change. So y plus -1 equals -1 times x is -x. -1 times 2 is -2. All that's left to do is add this 1 over here, and y is equal to -x plus -1. So, done with that. One thing I do ask you to be careful about is that with these, I didn't say write an equation in point-slope form. I said write an equation in slope-intercept form. So you do need to know the differences between which form that I want, and make sure you're paying close attention to those directions. All right, last page, story time. Okay, so you've learned how to recognize equations that are written in y equals mx plus b form, right? Because you're given one rate and a starting point. And you learned how to recognize when to write an equation in standard form because you're given two rates and a total. You're going to recognize when to write an equation in point-slope form because you're going to be given a rate of change and a solution point. So by solution point, I mean an x and a y, and the rate will be your m. That's how you will know. So solution point's not the same as b. It's not the same as one number as your y-intercept. It's an x and a y. So this is what they'll look like. Try it. It's math story time. You are pulling down your kite at a rate of 2 feet per second. After 3 seconds, your kite is 54 feet above you. Write an equation in slope-intercept form that represents the height y in feet of the kite after x seconds. At what height was the kite before you pulled it back in? Okay. Now this one you might think, oh, well, maybe there's a 2 feet per second and I see 3 seconds. Are those both rates? They're not. This says per. So when it says you're pulling your kite down at a rate of 2 feet per second, that means that this is my slope. But if you're pulling the kite down 2 feet per second, that means your slope would be a -2. Now this says that after 3 seconds, your kite is 54 feet. And this says that x is seconds, and you're supposed to be using y for the height, right? So you're given an x and a y. You're given an ordered pair of 354. So from this problem, we know we want to write it originally in our point-slope form because you're given the slope and you're given one solution point from it because you're given a value from each one of the variables. Okay, so step 1, we want to write an equation, and I want that equation to end up being in slope-intercept form, but I can't write it in slope-intercept form from what I'm given here because I don't have a b. So we're going to use y minus y1 equals the slope times x minus x1. And then we can go ahead and rearrange this equation to put it into the slope-intercept form that it asked for. So I'll keep change first. And I'm going to distribute this -2. Now I need that 54 to go away. So y equals -2x plus 6 plus 54 is 60. So that's our equation. We've got that part down, but that's not the end of this problem, is it? The last thing says, at what height was the kite before you pulled it back in? Now, think about this for a minute. Your kite's all the way up in the air, right? That's like your starting point, correct? Before you started pulling the kite back in, I want to know where it started. So, what represents the starting point in an equation? Doesn't the y-intercept represent the starting point? So now that you have your equation written in y equals mx plus b form, the answer to that question is this 60. It was at 60 feet before you pulled it back in. That wasn't so bad, was it? Alright, last one. This one's about parasailing. That sounds like fun. I would love to try it. Alright, you finished parasailing and are being pulled back to the boat at a rate of 10 feet per second. So it just said at a rate of 10 feet per second, right? So that's our slope, but you're being pulled back to the boat at 10 feet per second, so that would make it -10. After 2 seconds, you are 35 feet above the boat. So there's one variable, there's the other, there's your ordered pair. Write an equation in slope-intercept form that represents the height y in feet, so this is your y, above the boat after x seconds. At what height were you parasailing before you were pulled back into the boat? Alright, why don't you pause me and try to do this one on your own, because the other one we did is very, very similar to this. Or not, you know, we could just do it together, whatever works for you. Alright, so in this, I'm going to start off, I'm given the slope and a point, so I'm going to plug it into my y minus y1, and remember we said feet were the y, and I'm supposed to multiply my slope by the quantity of x minus x1. So you do have to know what's what, and the problem should tell you which variable is which. Alright, I'm going to keep change, so y plus -35 equals -10x plus 20. And now I want this 35 to go away, so I'm going to add 35. So y would equal -10x plus 55. So there's my equation. Now to answer the question, how high were you before being pulled back into the boat? I'm just asking you for your starting point. 55 is it. The y-intercept is your starting point. So 55 feet would be the answer to the second part of that. And that, I think, is all you need to know at the moment for point slope form. See you tomorrow.